Mm. Hmm. Hello guys, I'm audible. I'm audible guys. Yeah, that's it. We have chosen this platform because we can communicate here also. So communication will be proper there and technical issues and all that. So this is a good platform to discuss. Okay. So guys, today our topic will be about the reinforcement learning. Okay. So in the machine learning part, we have the supervised ML and unsupervised ML. But whatever the best technologies that you are going to see into the future guys, it will be going to heavily based on to the reinforcement learning. Okay, so reinforcement learning is going to create some good job roles. Okay, so in the reinforcement learning part, you will be getting some job roles regarding LLM developer, artificial intelligence developer, and those kind of NLP data scientist and all those. So it is going to come under the reinforcement learning part. So that's why earlier the people was not able to focus on to the reinforcement learning, and it is very possible that many of you didn't heard about it also. So in the future it is going to improve more, and we are going to focus upon more into the reinforcement learning part. Okay, so today our basic idea will be about to understand what is actually the reinforcement learning and what kind of works is going to be done into the field of reinforcement learning. Okay, so let's just try to understand. So let's start with some basic example first. Okay, so what is reinforcement learning? If I just tell you to Google onto that part, so on the Google there is a very complicated definition is present. So we are not going to go into that complicated definitions. We are here to understand it only what is the thing and how we are going to approach that. Okay, so I hope my okay. Let me just share my screen also. Yes. So I hope my screen is also visible. Meanwhile, people are still coming, like any people. Okay. So suppose, guys, uh, I'll not allow anyone after this, after 8:10. 41 peoples are there, but still many peoples are still trying to connect. Okay. So in the reinforcement learning part, guys, what happens? I hope my screen is visible. First of all, everyone, please tell me my screen is visible. Okay, that's great. So in the reinforcement learning part, suppose we have an environment. Okay, so this is an environment. Now in the environment guys, it can be any kind of environment. Suppose you are sitting in your room, so your room is your environment right now. You are walking, road will be your environment. You are in the classroom, so classroom will be an environment for you. So suppose there is an environment, and in that environment you are present there. And right now, suppose any person is present there. Still many people are trying to come. Okay, so suppose any person is present there. Now as a human intelligence, what we do into that environment, we do some sort of actions. Suppose you are present there, you walk into the environment, you walk and you go and you take your water. Suppose right now in your environment you have a aim, you have a aim to drink, take water and then drink the water. Now human intelligence are smart enough, very smart enough, that he know if you wanted to go and to take water, you know the path for taking the water. Every day you walk it there, you are living into that environment, you know what is the path to take the water, and then you can drink it. Okay, but obviously our agent or robot does not know anything. In the a definition part of it, everywhere you will be seeing the agent, but I'll be referring it as a robot because robot we understand a lot. So suppose you have a very normal and very basic robot, and he does not know your environment. Okay, but he wanted to take some actions. So what is actually the reinforcement learning guys? So reinforcement learning, suppose your robot or agent wanted to take some action in your environment. So what he wanted to do, he wanted to take some action in your environment. Action can be depend upon what? Action can be depend upon your goal. Your goal is right now to take the water. Now our robot goal is also to take the water part, it water here. Okay, still many people are coming, it's disturbing me a lot. Okay, no issues. So still our robot goal is to take the water. Okay, suppose the goal of the robot is to take the water, and now based upon that goal, your robot is going to take actions. Okay, and now first of all, whenever he is going to go into that environment, he is going to experience that environment, and then he is going to take multiple decisions. It will be not just a single decision, he is going to take a lots of different decisions. But ultimately, at certain point of time, he will be knowing your environment, and then he can take any kind of actions. And after he takes the action, he is succeeded with that. Okay, now reinforcement learning is that kind of like a job. Reinforcement learning, in the reinforcement learning part, what happens, you have a some sort of environment there, and now your robot or your agent wanted to take some sort of action in your environment. That is still based upon what, that is still based upon your goal. Your goal was to take water. Suppose at the different scenario, your goal will be some sort of different thing, like to walk, to go, like to write something. Okay, so goal can be changes, but reinforcement learning is focused onto that part, that your agent is going to take the action in a certain environment, or your robot is going to take the action in a certain environment based upon your goal. Okay, that is about your reinforcement learning. And obviously we can have like how he is going to take the action, whether the action will be good or bad, whether he is going to reach the goal or not, how he is going to reach the goal. That is the discussion part. And how it has been done, entire reinforcement learning is going to elaborate that part. Okay, so reinforcement learning as a definition wise, it is very easy. If you just google it, that will be complicated definition, but understanding purpose is what, suppose someone is asking what is reinforcement learning. So reinforcement learning is nothing but your agent is going to take some sort of action based upon the, obviously in the environment, based upon the goals. Okay, the actions can be good or bad, the actions can lead to reach the goal, or the action can lead to fail in the goal also. It can be having various possibilities, and that possibilities we are going to understand how our agent is going to take the actions, how our robot is going to take the actions. Okay, now guys, reinforcement learning is based upon the actions. Okay, based upon certain goal. Let's try to discuss about that actions and the goals. Okay, what I'm trying to do, let me just remove all this thing. Okay, let me put this thing. Okay. Suppose yesterday we have taken the example for it, but today also we are going to take the same example, because now we are going to understand in more, little bit more in depth. Okay, now try to understand, this is a sort of simple sort of maze. Okay, maze. Now into that maze, we have some sort of agent here. Agent, whenever I'm referring the agent, you can understand robot only. Robot, agent, it's a kind of same thing. Okay, robot is just not a humanoid robot, guys. Try to understand, robot is nothing like a only going to lead with the humanoid robot. Robot is can be in any form. So that's why I'm sometimes going to call agent or robot. So suppose here is our agent. Okay, now here this agent have to reach which part, have to reach the winning zone. Okay, what is my goal right now? My goal is to reach winning zone. Winning zone. So my goal is decided, my goal is to reach the winning zone. And now what are the actions we are going to take to reach the winning zone? If you see there, guys, if I ask you, and then like ask you, what are the actions we are going to take to reach the winning zone? So you can rightly say, because our human intelligence are so smart that we can say, okay, actions will be going on to this direction, then on to this direction, then on to this direction, then into this direction, and we'll be reaching our end goal also. And we can also go with this direction also. But we are able to make the decisions because our brain is smart enough that we can make the decision, and our agent will reach at the winning zone. But try to understand as a perspective of our robot or agent. He does not know anything. He is new in environment, and now he have to reach the end goal. How he is going to reach the end goal? That is a problem there. Then what happens, guys? Later on, like our artificial intelligence part, and especially the reinforcement learning part, guys, it was started a long back. Like I can say, it was started in 1950s only. But due to the lack of technologies, due to the lack of our processors and storage, people were not able to make such good technology into the field of artificial intelligence. But theories were coming in late 1950s, and then multiple new theories were coming into after that. So this problem was explained by a famous scientist called Bellman, Richard Bellman. So we came to know about a Bellman equation. Okay, so Bellman have given the like a equations for your agent, how he is going to reach the winning zone. Bellman have given that thing. Okay, but after Bellman have given in 1915, and he created the Bellman equation, then later on more upgradation has arrived. Like after that, we Markov have given his laws, Markov decision laws that we call. And then after that, Q learning arrived, and now the research is going on to the Q star learning. That is the next gen technology, you can say, next generation technology. But we are going to start with from very basic, so that we can understand what is happening, what is not happening. Okay, now into the reinforcement learning, guys, everything is works on to two factors: reward and penalty. This is the basis of your reinforcement learning. Name any technology or any part, whatever we have in reinforcement learning, whether it's a Q learning, whether it's a Markov decision law, whether it's a Bellman equation, whether it's a deep Q learning, everywhere this system is going to work. So we have to understand the system first of all. So the basis of these two system are, guys, reward and penalty. Reward and penalty. We have to understand what is reward and penalty into the like our reinforcement learning. Now, if we wanted to understand the reward, what is the reward? So we have a very good example regarding the reward. What we can say? Any problem is, guys, there? Just a second. Four peoples are there. Okay, no issues. So we have to first of all understand about the reward and penalty. In reward, what happens generally, guys, we can understand with our if you have a pet, then you will be better knowing about that. So suppose you are having a pet and you are a pet owner. Now you wanted to make your pet understand some sort of actions or anything else. Suppose you wanted to make your pet sit there. Okay, so you are continuously saying to your pet, okay, just sit, sit, sit. He's not trying to understand that part. But after he suddenly sit there, you give him some sort of food as a reward, like you give some biscuit or anything else. Then what happens? Your pet's conscious mind will understand, okay, whenever my owner is saying sit, then I'm getting a food as a reward, I'm getting a biscuit as a reward. Okay, now he next time whenever you are going to tell sit to your pet, the next time what is going to happen, he is going to understand properly, and he is going to obey your all commands whatever you wanted to do. But sometime what happens, sometime if you are saying something to your pet, then what will happen, he is not going to obey you. Okay, then what you will do, you will give him some sort of penalty there, some form of penalty you can give, like some punishment, or you like any kind of penalty you can give at that time. Now, this same system works for our agent pretty much very well. Whatever we understand into the field of artificial intelligence, guys, whether you discuss about any topic, whether it's a deep learning, natural language processing, whether it's a machine learning, it is just got from your real environment. It is just taken from your real environment. I will explain you all the parts. I will explain you about the deep learning also, and you will be understanding. Okay, it is nothing but the real world. Whatever is happening in the real world, we are just trying to mimic that artificially, and that's what artificial intelligence is going to make the changes. Okay, so same reward and penalty we are going to make it here. Okay, now suppose our agent is at this place. What happens if he's trying to make an action at a specific place? Suppose he was into this state and now he's trying to go in another state. He is now present into this state. Okay, so if this state is more closer to your winning zone, then what we are going to give, guys, we are going to give the reward to your agent. So suppose our agent is going into any next state, he reached at this point. Okay, our agent has reached at this point. Now what will happen if our agent has reached at this point? Just a second. Hmm. So if our agent has reached at this point, what we will do actually, what we are going to do, we are going to give him a reward. And obviously in the term of mathematics, or we can't give food to him. Okay, so what we are going to give, we are going to give the reward as some sort of plus numbers. Okay, so suppose we are giving plus 1 marks to our agent, so he is accumulating that marks. Try to understand, our robot is accumulating that marks. He got plus 1 marks there to reach that state. Okay, now he is taking new step, he is taking another new step. What he is trying to do, he is trying to go in another state. Now he is reached into this state. Okay, you again given him some rewards. What you given, you given plus 1 marks to more, so he is accumulating that numbers. Okay, next time what happens, he is trying to reach your winning zone. Okay, he's trying to reach your winning zone. He was in this state, now he reached into this state. Obviously you are going to give plus 1 reward for it. Okay, now at the last what happens, he has reached your winning zone, and now you will be giving your final reward. You can give like sometime what happens, we give more reward for the final, but right now try to understand, I'm giving one more reward, that is plus 1 again to it. Okay, so what happening to our agent, he's trying to accumulate the rewards there. He will be greedy at that point. He wanted to accumulate more rewards as he can do. Now try to understand, at this point he reached at the winning zone at the particular states, from this state to this state, from this state to this state, from this state to this state, and now he has reached the winning zone. That was our goal, and our goal has been achieved by the agent. Okay, by giving him what, by giving him more rewards. Now try to understand another scenario. What the scenario, what is the another scenario we have? Suppose our agent is trying to do some sort of mistake. What mistake he is trying to do? Let's try to understand. So our agent was here at this point. At this point our agent was at this point. Anyone else is coming? Okay, from tomorrow on I'll just put there like everyone come on this like a sharp 8. Okay, so try to understand our agent at this state, he is in this state. It can be any, in any state, guys. It's not like that every time our agent will be at this position only. He can be in this state also. Now our agent in this state, and he wanted to ultimately reach our winning zone. Ultimately our goal is what, to reach the winning zone. What he's trying to do, our agent, he trying to take some step like this one. He's trying to go in fire. Try to understand, our agent is trying to go in fire. So if our agent is trying to go in fire, then what will happen? He is going to lose the game, and if he's going to lose the game, then what will happen? The game will be over for him. So what we can do to him, that he does not go into that fire? What we can do with that, we can give him a form of penalty. What we are going to give right now, penalty. Suppose your dog is not obeying you, so what you will give, you will give him some sort of punishment or penalty there. So if our agent is going in some sort of fire, then what we are going to give, we are going to give him some sort of penalty there. And penalty which will board, obviously we are not able to give him punishment like the real world that we are going to give. We are going to give in term of maths, so we are going to cut his 1 marks there. So he was trying to accumulate the rewards, but suddenly he is now getting what, penalty also. Penalty in form of what, subtracting their accumulated marks. So he's now getting minus 1 marks there. Okay. Whether our agent want minus 1 marks, whether our agent want penalty, obviously he does not want our penalty. He just wanted to get more reward as he can do. Okay. So next time what will happen whenever he's trying to go into the fire, okay, he understand this thing. He will understand this thing. Okay, whenever I'm going into the fire, I'm getting penalty. If I'm getting the penalty, then obviously what will happen? If I'm getting the penalty, I will not able to accumulate that much marks there, and I will not able to reach the winning zone. Okay, so this is what our reinforcement learning work. This is how our reinforcement learning work. Okay. I have just given you the form of reward and penalty. Why? Because this is the basis of your reinforcement learning. If our agent is moving to your winning zone and with the optimal paths, what is necessary, guys? With the optimal path. Why I'm discussing about the optimal path, guys? Because he can go here and there, and then he's trying to reach the winning zone. So longest path, we are not wanting longest path. Optimal path to reach the winning zone, he's trying to accumulate the rewards at that point. Okay. If he's doing any mistake, if he's taking any kind of action that is leading to any kind of mistake, what we are going to do? We are going to penalize him. We are going to cut his marks, minus 1 marks. We are cutting it right now. Artificial intelligence, if I'm telling you guys now, I can tell you in term of whole mathematics. I know this thing. Okay, I can tell you in entire mathematics. I can write all Bellman equations, everything. But that I don't want right now. Why? Because I know many people are coming from that kind of background who does not having like a proper knowledge of mathematics or anything. So what I try to maintain, I try to start with some sort of theoretical things and all that. Then slowly we are going to understand mathematics behind it. Obviously, if like many people are there from my like batches only, whenever we were learning linear regression, we started to understand from the graph. But that graph equation, we have written every graph equation, whether it was our loss function, error function, gradient descendant formula, everything we have written there. Okay, same thing is like that. I'm trying to explain you as like giving reward and penalty, but who is going to decide the reward? Who is going to decide the penalty? That's where the equations are going to come. Bellman equations, Markov decision law, Markov decision processes, and then Q learning. Your Q star learning is like it's the research part of thing. Then deep Q learning. Okay, so these are the things. Let's try to dig more into deep into that, and let's try to understand the Bellman equation first. Okay, I'm not going to write any kind of mathematical formula, but if needed, guys, I will try to write it. Okay, otherwise I'll just try to make it as simple as that. Let's try to understand what Bellman have given there, what Bellman equation is telling us, and what Bellman have given the equation for it to get to the winning zone or your final like a goal there. Okay, let's try to understand now. So Bellman was the first scientist, in my opinion, like who started to actually give a very good contribution into the field of artificial intelligence. Then Markov decisions, like Markov's come. Then after that, Google started to work onto that part, like a famous chess game. If you have seen there, so the first robot was like a chess there, where artificial intelligence has been used there, and he have like defeated some like a most like what you can say the champion people of that time. So the robot have defeated those people. Okay, so obviously the reinforcement learning was put it there. Now let's try to understand the Bellman, what Bellman actually told there. If anyone having any kind of issues or doubt, please let me know right now. There is nothing, we are trying to understand and we are here to come only understanding. Okay, so if anyone having any kind of doubt, you can let me know. So it was our winning zone. It was a fire. I'm adding one more thing, guys. Let's just add one more thing. Uh, Let me try to add one more thing there. Okay. Now this is, suppose this is a rock. Still, how can people come at this time? They're not taking anything seriously. Okay, so this is a rock I've designed. Like I've just put it some rocks there. Now let's try to understand what Bellman have actually given. Now I don't want you to write any Bellman equation there, but still. So here we have our agent. Now our agent goal was what? To reach the winning zone. Okay. So our agent goal is ultimately to reach the winning zone. Now try to understand, guys, what can be the optimal path. First of all, if I ask you what can be the optimal path, you will be saying that this will be the optimal path for it. We are going to reach into that state, then move into that state, then move into that state, and our agent is going to reach at the winning zone. But other than these paths, can we have other paths also? Suppose we are giving him just plus one marks every time. We are trying to give him plus one marks every time. So our agent is so much greedy that he is every time is going to like get that one marks. Okay, he is every time going to get the one marks. But try to understand, if he is going into this direction, what marks you are going to give? Plus one, plus one. Everywhere you are giving plus one only. Okay, what will happen at the time? He will not reach the winning zone. What will happen? He will just try to accumulate more marks there, because plus one you are giving right as a reward right now. Na? So what he will do? He can go from this state to this state. One marks got, two marks got, three marks, four marks, five, six, seven, eight, nine, 10. Every time he's just accumulating the marks there. He's not trying to reach your winning zone. Why? Because you have made the same marking for each state. This box, what we can call it, guys, we are calling it as a state right now. Okay, so what it his ultimate goal is to reach at the winning zone. But what he's trying to do, he's trying to get more marks there. How he is getting more marks? Just traveling here and there. He's going into this state, got one marks, one marks, one marks here, one marks here, here one marks. So he's trying to accumulate more marks, and ultimately is not trying to reach into the winning zone, and that is the bad thing that is happening there. So Bellman have given some sort of equation that was solving this problem. Bellman have said this thing, that our agent, our agent, okay, is not going to get equal marks, guys. Listen carefully. Our agent is not going to get equal rewards. He is going to get different rewards there. This is the easiest way that I can tell you the Bellman equation. Otherwise, if I write max of RSA and all those things, you will be confused at that point. I don't want to use any mathematical formula there. Okay. So Bellman have tell that if I try to give only as a single reward for each state, our agent will not able to reach at the winning zone. So what we try to do? So whenever he's trying to, just see how smartly he have figured out that part. So whenever he's trying to reach the winning zone, we are going to give him plus one as a marks. Suppose we have given plus one has as a marks there. But before reaching the winning zone, he will get little bit less marks. What marks he is trying to get? He will get 0.81, suppose, or 0.81. Then he's trying to get before that, how much marks he will get? 0.57. Then here, not 0.57, it is very less, so let's just make it a little bit more, 0.73. Then he was getting into that state. In this state, what he is getting? 0.68, 0.58. Okay, now try to understand, if he wanted to get more marks, then he have to go into this direction, and now he's not getting equal marks. So what will he try to do? He will try to remember the things. So he's thinking, okay, I am getting into this state, so I'm getting 0.58 marks. Okay, if I'm getting into this state, I'm getting more marks. If I'm getting into this state, I'm getting more marks. If I'm entering into this state, I'm getting more marks. But if I'm finally reaching at my winning zone, I'm getting the maximum marks there. I'm getting the maximum marks at my winning zone. Okay. Now Bellman have figured it out this. Obviously, these number whatever I have written now, it was figured out from Bellman equation only. Okay. Now try to understand, if our agent is going into that direction. Okay. So if you see, this path was okay. This path has does not have problem. How many states he have to go? One, two, three, four, five states, and he's reaching in five step. He's reaching the winning zone. One, two, three, four, five. From here also he's reaching at the same, like a five step he have to take from this path. Okay, five step he have to take from this path also. Okay, So both are the path are same right now. So what I'm doing, I'm trying to make it the same value. So into this state 0.58 value, into this state 0.68 value, into this state 0.73 value, and already it was 0.81. So let me just write it inside that state, then it will be more good. So here it will be 0.73 I've written 0.81. So if you see guys, huh, both paths are correct, there is no issues at all, both paths are correct right now. Okay, so here our agent is going into this direction, he's reaching the winning zone. Our agent is going into this direction, he is reaching the winning zone. But try to understand, if he's not able to take the optimal path, suppose after reaching into this state our agent is going into that direction, it is very possible that rather than going upward, he can go on to the right hand side. So into this state we are going to give him the less marks, 0.38, suppose he got it 0.33, he got it. Okay, so he's getting less mark. But suddenly if he's reached into the fire, then what we are going to do, we are going to penalize him, we are going to give penalty. So obviously our agent does not want any kind of penalty, he wanted to collect as much reward as he can. Okay, so now the optimal path that was explained by the Bellman, this was the path: first, second, third, fourth, and then fifth. This was the one path, and this was another path for it. Okay, this was the two path that we got it. And obviously these number will be defined by the Bellman equations only. Now try to see what is the benefit of giving different rewards for each state. What we call this thing guys, this box, we call it as a state. What is the benefit? Because this time equal reward he is not getting for getting in each state, different reward he is getting. So our agent, what he wanted to get, more marks he wanted to get. So into the greediness of more marks, he will ultimately going to reach at our winning zone. So he will reach from this state to this state, accumulating more marks. He got more marks into this state, he got more marks into this state, he got maximum marks from this state, and now he is reached at the winning zone. Okay, and that was explained by the Bellman. And if you search on the Google, so there was a Bellman equation, I don't wanted to write it because I wanted you guys to understand in regard of the artificial intelligence how it works. But Bellman had some issues guys. Are you guys able to find out any kind of issues into this? Bellman had some issues. Anyone can tell me what kind of issues we had into that part? Anyone is able to understand? Real world example, guys. Just a real world example. I don't like a in real world what you wanted to do there. Just take out what can be the problem into this, like giving different rewards, and we have a two path also. Just try to see this path, this path. I'm naming this path. I'm naming this path as my first path, guys, and I'm naming this path as my second path. So this is our second path, this is our first path. Now try to understand which path you will choose. If you are a human, because human intelligence are every time smart enough, I wanted to ask you guys which path you guys are going to choose into this thing. First or second, guys, I wanted to know this thing. First path you are going to take to reach the winning zone, or second path you are going to take the winning zone. Obviously the number of steps is same in both of them. One, if you see 1 2 3 4 5, 1 2 3 4 5, number of steps are same. But I wanted to ask you which path you are going to choose, first path or second path. Guys, tell me which path, first or second? First path, second, first. Still like first. Okay, first. Second for more points. Second, how second can get more points, Wasim? Second cannot get more points. Equal points we have: 0.58, 0.68, 0.73, 0.81 plus 1. Same points we have now. How you can get more marks? Actually, guys, you wanted to take a risk of getting in fire or not? Just tell me. If you are taking second, in first path, just try to understand. If I'm choosing the first path, so let me just take any other color for it. Okay, if I'm taking the first part, this one. Now in this path, whenever I taken first step, what was the chances? I can go upward, I can go right hand side, I can go downward also. Okay, Every state have these chances, guys. Suppose I am in a state current state. So what are the steps I can take? Either I can get left, I can get upward, either I can get right side. Okay, so I can get in any state, I can take any kind of I can go in any kind of state by taking these steps. So these are randomness, guys. So it's not fixed like every time he's going to go upward, every time he's going to go downward. It's not like that. Okay, so if you try to see there, whenever I'm taking this path, I went into this X state. So I went it here, got it, no issues. I went into this state, got it, no issues. I went into this state, got no issues. But try to understand, if our agent is present into this state, what is going to happen? His action is what? Either he can go upward, either he can go right side, either he can go left side, either he can go downside also. There are four actions right now. Downside also he can go. Now try to understand. So whenever he is into this state, there is a chance to get into this fire or not? There is a very high chance to get in fire. High chances. So if you have a that much high chances to get that in fire, whether you are going to take that risk, or you wanted to go with this direction that does not have that much of risk, the first path, which path you are going to choose, choose there. Which path? Whether you wanted to get like a chance to get in fire and get penalized there and your game will be end at that time, or whether you wanted to take a decision, the first path, which was more optimal and who doesn't which does not have the chances to get in fire. Very less chances the first path have to get in fire, but second path having very high chances to get in fire. So, what do you think? Which path right now? First or second? First or second right now? Everyone is going to say first. Yeah, Anjali. Yeah, that is the first one. And now try to understand, whenever he's trying to get the first path, whether Bellman have solved that problem, whether Bellman had tried to solve that problem, that he is not going to take the risk of getting in fire. Bellman had not solved that problem. Then another scientist arrived there. The scientist's name was Markov. Okay, so he have created his law that is called Markov decision law and Markov decision processes. So with the help of that, this issue was solved actually. So right now, just see as a starting point of view, our AI is starting to get over smart us also. We'll be seeing some point and you'll be amazed there that we can train our AI in such a way that whatever we wanted to make him to do now, he is going to do. That's why it is very risky for the future also. That if I want my AI to kill someone, I can make that AI. Okay, and he's emotionless already. So that is the concern regarding the future also, and many top world countries are trying to regulate the AI part also. Why? Because it is very easy to manipulate the AI, guys. Okay, what happens if I'm giving him the reward for getting in fire? Try to understand. Getting in a fire, it's not a good job, it's a bad job only. But if I am trying to give him reward to get in fire, so he's going to go to into the into the greediness of the reward, he's going to get into the fire only. Okay, so that is the thing. That's why AI is very risky in the future also, and that's why we are the people, we are trying to create a peaceful AI. We will be trying to create a peaceful AI. Okay, now into that equation we have understood Bellman was giving same marks to this path also, Bellman have given the same marks to this path also, and that was the problem has arrived. Now Markov have introduced a new thing into this entire processes. Okay, so that why we call it as a Markov decision process and Markov decision law. The name is that. In starting of artificial intelligence and reinforcement learning, guys, we have to understand these things. Okay, so Markov, what he did actually, let's try to understand. And everything I'm just going to explain you in term of numbers, no, not at all any kind of mathematical formulas. Okay, so again, so three lines are we drawn. Three lines we draw. This was our rock, this was our fire, and was our winning zone. Okay, I guess now you guys understand. Now Marco, what he was trying to do, guys, Marco did not pretty much, sorry, Bellman did not pretty much explain the actions from the state what your agent or robot can take. If your robot or agent in a certain state, suppose my robot in a certain state, Bellman have ignored that part. So our agent, what he was in certain state, he can take various action. He can go upward also, he can go in right hand, like right side also, he can go in left side also, he can go in bottom also, guys. He can like do that thing. He can hit his head into the rocks also. So he have lots of possibilities. So he can go in all the direction. Okay, suppose our agent is going from this direction to this direction. Now there is whenever he reaching into this direction, he can hit his head into the rock. He can go upward also, he can go onto the right hand side, he can go downward also. Okay, now try to understand what is happening. The problem was that into this state, if he is going into this state, there is a very very high chance that he can go into the fire and he can end his game. Now this problem was solved by your Markov. And how he solved the problem, he have considered the steps, he have considered the action and the action that your agent can take. Okay, let's try to see what action your agent can take. Okay, now our agent was somewhat here. Let's try to understand. He can go upward, right hand side, this side, this side. Okay, now he is doing all this thing. He can go in all the four direction, but ultimately he's not dying right now. Na? He's not ending his game. Okay, suppose he go into this direction. Okay, he reached into this state. He went into this direction. He reached into this state. Okay, now there is a whenever he's taking this kind of partner, he's getting more risk. He's getting more risk of ending his game. Now Marco, what he did it, obviously he have followed the Bellman equation that giving different marks. So plus one marks or final marks, he have given maximum marks to reach the winning zone. So plus one is like just a number, guys. Don't understand like every time plus one 0.8 this kind of number. It is just a number that is defining, okay, whenever we are reaching the like a winning zone, we are getting maximum number there. Okay, so what your Marco understand, different rewards we have to give. 0.81 done. Let me just write it inside it. So 0.81 done, 0.73 done, 0.68 done, 0.58 done. No issues at all. But Marco, what he have given, he consider the street. What I am trying to explain, he can go upward, right hand side, left side, downside. He consider this state into his Marco decision formula. He consider this thing. Okay. Now, whenever our agent is going to go into this direction, what is going to happen? He is not going to give the same marks. He's going to get less marks there. 0.48, 0.36, 0.28, 0.31, or sorry, 0.38, suppose 31. Okay, so now he is not able to accumulate, our agent is not able to accumulate that much marks as he was getting from this path. Now he's getting less marks to this path. Okay, so that what your Markov has explained. And obviously I'm giving you just number, I'm not writing any formula. Why? Because artificial intelligence reinforcement learning, guys, it is just not going to come in just a one day. It is going to take some time. We have to invest our time. Trust me, I have invested my days and night into these things. Okay, to understand these things and try to make you understand regarding it. Because if I just try to give you the formulas and how it's calculated, you'll be stuck, will be not as understanding, and there is no proper content available for this also. So from here and there, Google and all this did all of these things, then I understand the AI part clearly, very clearly. Okay, now after Marco have given, it was also having some issues. Then after that, what happens? Q learning arrived there, and then Q learning was more optimized. That's how our the process of any things works now. It started from the base, then it increased the like it gives some other versions, like you get it better, 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 better. So up to the Q learning, we have it. We have the very good technologies regarding the Q learning. Your Chat GPT. it's based upon the q learning. Your any kind of self driving car, everybody heard now. Self-driving car is nothing but, guys, try to understand that as a robot. Self-driving car, understand it as a robot. He have to take some action. Suppose any kind of car is coming in front of him now, suddenly he have to take some action into that part. Okay, so everywhere up to the q learning we have a very good kind of technologies. But q star learning, that is all, it's going in research part. Okay, so next time, like q star learning, if it is arriving, so you will be seeing that much advanced technologies like that can predict the futures. So if anyone have seen the mission impossible also, so mission impossible was there was a villain totally. Okay, so the kind of technology was villain into that mission impossible. It was based upon q star learning. And that's what agi, artificial general intelligence, is going to arrive into the future. So future is like that way. And India, what it is happening, guys, frankly speaking, when I started to learn this artificial intelligence and all that, in India there is nothing I can see regarding it. In foreign countries, everything is happening, whether it's a Japan, USA, and all those, these things are happening. But in India, not kind of enough things I'm able to see regarding it. Okay, so that's why I thought, let's try to educate the people regarding it. Let's try to educate the people regarding the artificial intelligence, artificial general intelligence, Q star learning, have a research part of it. Let's develop some technology that we can work on to India also, and we can have a technology like a chat gpt that we have. Chat gpt, in my opinion, it is the most advanced technology that we have right now. Okay, and these guys are working on a q star learning, like a agi part. If that thing is arriving now, so the game is going to change. Okay, so I have just given you the, like a basic understanding what is reinforcement learning, guys. Now after that we have a q learning, q star learning, deep q learning. Whatever the technology you heard about it, guys, whether it's a deep learning, nlp, computer vision, whether it's a cloud technologies also, cloud computing also, whether you are doing machine learning, statistical analysis, data analysis, data science, everything is connected to each other. If I'm talking about deep q learning now, so you have to understand first of all deep learning, then you're going to understand deep q learning. Okay, so that's what I, after doing a lots of like a 3 4 years, I've given into these things only. After understanding properly, then I thought, okay, this was a correct proper process to understand all these things. Okay, so that's what we are trying to make it. And that's why we are different. We are trying to focus on those technologies who is going to work into the future. And many people, you are not knowing right now, but in the market many people are getting job regarding llm, many people are getting job regarding ai developer, nlp data scientist. It is booming right now. If you just go and search on linkedin now, nlp data scientist is the most search job right now into the market. Okay, so why? Because people wanted to hire the people regarding nlp data scientists, but like a recruiter does not getting any kind of skilled students regarding that. And that's why I'm telling you guys, focus on these technologies. Okay, don't rely on anything like a basic. Obviously those python, sql, and these things are basic. I know these things, these are basic, without that you can proceed it. But if you are not upgrading yourself for the future, you will be running behind. Okay, so that's what we have wanted to do. We wanted to upgrade ourselves there. Okay, so right now, I guess you got a little bit idea about the reinforcement learning, guys. I hope you have understand a little bit about it. But tomorrow we are going to understand. Let's just decide. I'll ping you on the mail, but just check the mail and please arrive on the time. If I'm investing my 1 hour now, you don't know how much costly my 1 hour right now. Okay, so I'm giving you free things right now to understand a certain technology. People who's not coming right now, they are not understanding what they are running behind. Okay, so I will request you guys from tomorrow on, please join on time, so that 1 hour we can invest to understand these things only. Okay, and I'm not going to take any kind of mathematical difference in starting. We are just understanding the technology, what is this and what we are going to work. And I'm submitting a form, guys. Please fill the form so that we can mark the attendance. And obviously many people are here for getting certificate na, so get the certificate also. So I'm going to ping a form there in the chat. Everyone just put that in a chat. Let me stop my sharing. Form. How I can get it? Okay, so let me just request my team member. Like this time, how the people can come at this time? Like I don't understand what happens. Like just making the attendance certifications. Why people are behind it? I don't know. They are not focusing on the knowledge. People are focusing. Get me this certificate, that certificate, that certificate. I just focus on the knowledge now. Okay, so let me just give it. Uh, Let me get the form. Wait for like 1 to 2 minutes maximum, guys. ब्यूटी 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 प्लीज कॉल समरजीत भैया तुरंत कि वो फॉर्म का लिंक हमारे पास भेजें. Otherwise, let me just do one thing. I can take a screenshot also. So, hey Siri, hey Siri, hey Siri. यार ये सिरी क्यों काम नहीं कर रहा है? Let me just see whether it's working today. Just wait for 1 to 2 minutes, guys. Yeah, I got it. I'll send you that thing only. Okay, just let me close this thing. Copy link. I'm putting in chat, guys, and please let me know. Everyone is able to fill the form. If you are filling the form, able to fill the form, just let me know regarding it. And can I pin it also? I put it in chat, guys. You see that thing? And let me know if you guys are able to fill the form. Okay, very good, guys. Meanwhile, let other people's or submitting it. Tomorrow, what I'm thinking, after understanding this reinforcement learning, you guys should get a knowledge about like a DL, how deep learning works. And tomorrow you'll see like whatever the technology we have it is just the implementation of your real world. You'll see how deep learning is actually working. You'll be amazed like it is just nothing but it is taken from your real world and that just implemented in machine and you got a technology called deep learning. Okay, so everyone is submitted that form, then I can end this call and we can end this meeting also. Yes, submitted. Let me just check it meanwhile onto the spreadsheet also how many people have filled that. Hmm. Yeah, you guys want PDF for that? From tomorrow because I'm so busy person right now. You don't know. So from morning 8 o'clock to evening 9 o'clock, just taking sessions. So let me try. I'll try to make it as a PDF and I will give you some content related to it also. So I had in my past. I'll try to give you some content related to it. Okay. So anything else? PD. Is anyone submitting the form? Projects. So this is the kind of internship, Vashim, where you guys will understand the things only. Okay. Projects. I can't do that thing. Why? Because if we are trying to do the project, people should have the knowledge of the technologies. Like if you are trying to do a project in artificial intelligence, suppose we should have that knowledge properly, how the formulas works and everything. So try to understand. Suppose we are trying to make a road, it can't build in just a one day. So it's a process, entire process. You will get a knowledge, you will guys will get a knowledge regarding the world of data science and AI. Then next time, yeah, let's understand, let's do one more things into the field of AI. Okay. So it's just like that only. So I can't if I just for this explanation, how you can expect like we can have a project regarding it. Okay, so done, guys, and hope guys will meet tomorrow and will understand deep learning. Might be deep learning only. So deep learning and will understand each technology one by one, and then what where from wherever you guys wanted to explore. Suppose you wanted to explore the machine learning part, deep learning part, you can explore that. And I will recommend you personally to do go into these field. There is better opportunities right now. Okay, so bye bye guys. Thank you for coming to the session. Have a good night. Take care.